Usually when you walk into a pine forest, you expect to smell, well, pine, damp earth, maybe some moss, stuff like that.
Right, the usual outdoorsy sense.
Exactly. You definitely don't expect to suddenly get hit with the overwhelming scent of a fresh stack of pancakes covered in maple syrup, or even a rich, spicy Indian curry.
No, it is a complete sensory mismatch.
It really is. So today we're doing a deep dive into a stack of mycological monographs and botanical histories to figure out why this tiny, unassuming fungus called the Curry Milkcap pulls off this bizarre trick.
And to understand the trick it's playing on you, we really have to look at how human history actually changes the way we describe smells.
Because the mushroom's chemical makeup hasn't changed at all over the centuries, right?
No, not at all. Just our cultural reference points.
Yeah.
Like back in 1792, the French mycologist Bouillard named it camphoratus because he thought it smelled like camphor.
Which is that medicinal sort of mothball scent used in old ointments. I mean, that makes perfect sense for the time.
Exactly. But then by the 19th century, Elias Magnus Fries, a famous Swedish mycologist, he was calling it the bedbug mushroom.
Wait, the bedbug mushroom? That sounds completely unappetizing.
It does, but it makes perfect historical sense. 19th century European homes were basically crawling with urban bedbugs.
Oh, gross.
Yeah. And when this mushroom dries out, it emits this musty Swedish odor that perfectly mimics their defensive secretions.
Oh, wow. So as modern sanitation wiped out the bedbugs, society just lost that scent reference entirely.
Right, so we shifted to things that were becoming more globally available. By the mid-20th century, we started calling it the Curry Milkcap, referencing global spices, burnt sugar, or, maple syrup.
It's kind of like an olfactory optical illusion. The mushroom acts as a historical mirror, but the weird part is, if you were to pick one of these on a hike right now, you wouldn't smell a thing.
Totally scentless. The aroma only appears after you pick it. Fresh tissue contains this inactive, odorless precursor molecule called quabalactone 3.
Quabalactone 3.
Right. And as the mushroom dries out or gets heated, this molecule undergoes hydrolysis, meaning water actually cleaves or breaks apart its chemical bonds.
And that cleavage converts the odorless precursor into a completely different molecule, right? Sotolon.
Exactly. A highly stable molecule called Sotolon. And it's a chiral molecule, which means
Meaning it has a specific 3D shape, like a left or right hand, that perfectly fits into the scent receptors in your nose.
it fits so perfectly that your nose can detect it at just 0.8 parts per billion.
Wait, parts per billion? That is incredibly potent.
It really is. And Sotolon acts as a shapeshifter. At very low concentrations, it hits your receptors smelling exactly like sweet maple syrup.
But if you increase the dose...
The perception shifts dramatically to an aggressive, spicy curry.
Okay, so does this mean the field test trick from our sources actually works? Like, if you're out in the woods and want to identify it, you can just burn a piece of the mushroom's flesh with a lighter?
Oh, absolutely. The intense heat forces that chemical cleavage instantly. It dumps a massive wave of Sotolon into the air to confirm what you've found right on the spot.
That is fascinating.
And that same volatile chemistry acts as a powerful defense mechanism. The mushroom contains compounds that act as a binary weapon system against insects.
Oh, right, like how a glow stick works. Keeping two harmless chemicals safely separated until you snap it, they mix and it glows.
Exactly. When a bug takes a bite of the mushroom, it crushes the cell walls, mixing previously separated chemicals to create a toxic, bitter defense.
Brilliant for fighting off bugs. But if Sotolon is that potent and stable, it must be, an absolute nightmare to control outside the forest.
You have no idea. It is a notorious formulation nightmare for flavor chemists. If Sotolon gets into a food manufacturing facility, its extreme stability means it permanently binds to the factual's rubber gasket.
Wait, permanently?
Pretty much. You try to switch the machines from curry flavor to something else, and you simply cannot wash it out.
Which brings up the biological side effect I saw in the medical notes. Because it's so stable, our bodies can't break it down either.
No, we really can't.
So wait, if you eat a dessert flavored with curry Milkcaps, Sotolon passes through your system completely unchanged. It hijacks your biology, making your sweat and urine smell like maple syrup.
Yes, the infamous maple sweat phenomenon.
So this highly prized gourmet ingredient basically treats us the same way garlic does, turning us into the aroma conduit.
Exactly. It highlights how chemical stability is a double-edged sword. It preserves human history through scent, creates incredible culinary magic, but also causes absolute industrial contamination.
There is one potential loophole in all this stability, though. The botanical notes mention a fungal parasite called Hypomyces camphoratus.
Right, the one that infects the Curry Milkcap in the wild.
Yeah, and when it does, it totally suppresses that famous Sotolon aroma. If scientists can figure out exactly how this parasite neutralizes such an indestructible chemical.
Could that be the key to finally cleaning up those permanently contaminated flavor factories?
Exactly. Nature might hold the antidote to the very problem it created. Something for you to chew on next time you smell a stack of pancakes out in the woods.